Okay, so first section we're going to look at this week is 3.4, and it's on graphing equations that are written a little bit differently than y equals mx plus b. They're going to be written in what we call standard form. All right? So it's still a line, it's just a different way of writing it. So I'm going to show you guys how to graph it. Okay, so on your guided notes, the first blank you have says the blank of a linear equation is, you want to fill in standard form. And then I'm going to tell you what it is. Before I give you that, can somebody remind me, what's the other form that we use for a line? We just wrote it in the warm-up. Yeah? Y equals mx plus b. Y equals mx plus b is called slope-intercept form of a linear equation. Okay, this is standard form. You guys already saw a couple examples of standard form. Right here. That's standard form. Okay. The y isn't by itself. Okay. Same thing here. The y isn't by itself. Okay. But we've practiced and we know that we could get the y by itself if we minus the 2x to the other side, and then we'd have to divide by 3. You guys did that on the last test, right? You got it by itself. So, slope-intercept form looks like that. It's basically a number times x plus, or it could be a minus. I'm going to put plus or minus, depends on the problem. And then a number times y equals a number. The a, the b, and the c are just numbers. Okay, they're all numbers. And when I say real numbers, that just means they could be fractions, they could be decimals, they could be positives, they could be negatives. One thing we got to be careful about is a and b can't both be 0. One of them could be 0, but they can't both be 0. Because think about what happens if they were both 0. What's 0 times x? 0. And if b was 0, what's 0 times y?
0.
Now you've wiped everything out on that side of the equation. You don't even have anything there anymore. We can't do that. Right? We can't wipe everything out. One of them could be 0, but not both. That's what that last part says. All right. So somebody give me a number for a. Any number you want. Positive, negative, fraction, decimal. 15. So I'm going to plug in 15 for A. Okay. How about a number for B?
69.
69. Positive or negative?
Positive.
Positive. 69x equals, give me a number for C. 20. That's an equation in standard form. Except I should put y here, not x. That's perfect. That's an equation in standard form. All right. We're probably going to work with numbers that are a little smaller, kind of like I did in the warm-up, but you could have big numbers as well. All right. Now, there are two special cases. Okay? And the two special cases have to do with if one of those is a 0. Nobody gave me a 0. Okay? We got 15 for A, we got 69 for B. Neither one of them was 0. But let's look at special case number 1. If you have an equation of the form y equals a number, y equals 2, y equals 5. Okay, the point is there's no x. That is a horizontal line. Right, I'm going to show you guys an example with a picture. Okay, so the only way you would get y equals a number is if you plugged in a 0 right here. Because if you made that a 0, 0 times x would be gone. Now you just have a y. Okay, that's the only way that could happen, if you plug in a 0 for x. Okay? that's an example of an equation of a horizontal line. Okay, it's a lot simpler than y equals mx plus b. Okay, it's just y equals a number. So on your special cases, you guys got a graph right below special case number 1. You can draw that graph in. Okay, so y equals, and then in that box, you put a number.
Why is it there?
Y is what, where?
The y equals 3, why is that there?
That's an example.
But like...
That's an example of the equation of a horizontal line. That's what it looks like. So in this case, y equals, what number is in the box? In our example I wrote down. 3. So what that means is, I think my line is 1 off though. Should be right there. Y equals 3 means you put a horizontal line 1, 2, 3 units up. And that's it. That's what a horizontal line looks like. It's a lot easier when you only have one letter in the problem. When you do a problem like we're going to do eventually, like this, when you've got 2 letters in it, it's a little harder. When you have 2 letters, your line is going to be on a slant. It's not going to be horizontal, it's not going to be vertical. It's going to be slanted. Okay? When it's slanted, then you got to find 2 points. That's more work. But a y equals and just a number like this one, super easy. You just do a horizontal line and you just do it at the number they tell you. Okay. So that's what the equation of a horizontal looks like. Does anyone have a guess what a vertical is going to look like? It's almost the same kind of equation, but you change one thing in how this equation looks. Yeah? It's going to be x equals. So, special case number 2. If you have an equation, x equals a number. X equals is vertical. Now, I know you might be thinking, well, wait, when we draw the x-axis is horizontal. It's not vertical. You're right. So this is a little tricky to remember. Right? But you could definitely put it on a reference sheet, and you can use that on the test on Friday. So if you have an equation, x equals a number, that's a vertical line at that number. Okay, so let's look at this one. You guys get another graph to sketch that. What kind of line is this? Is that going to be vertical?
Parallel.
Or horizontal? Well, to be parallel, I'd have to give you 2 of them, right? I'd have to give you 2 of them and say, okay, look at the red one, look at the blue one. Are they parallel?
It's vertical.
But how do you know that that's vertical?
Because it's x.
Because it's x, right? If it's x, it's vertical. If it's y, it's horizontal. Okay, let me check, make sure I did that one right. 1, 2, 3, 4, yep. It's a vertical line, and then you put it at that number.
Can you go back up?
Yep. So vertical line at that number. These are the easiest 2 cases that we do. Yeah. Yeah. Okay, so how do you tell if it's horizontal? What's the equation going to look like for horizontal? Yeah? Y equals, yeah? What's the equation going to look like for vertical? It's going to look like x equals. Yeah. Other than that, if you've got both letters in the same problem, an x and a y, it's going to be slanted. Okay. But we'll go through how to do a slanted one. Okay, so let's look at this. Okay, so example 1 says graph the following. Okay, we've got y equals 4. Okay, so first thing you got to figure out is, okay, does it have both letters in it? No, if it had both letters, it would look like that. That's got both letters. This one just has 1 letter. So we say, okay, 1 letter means it's special. we got to figure out if it's horizontal or if it's vertical. That's the first thing. Yep.
It's vertical.
Why?
Because it has the y-axis.
All right, let's go back and look. So special case. You said it because it has y, it's vertical.
I meant horizontal.
Horizontal. Y equals is horizontal. Okay, so we know it's horizontal. Now we got to put it at the number 4. So, James, which way is 4? 4 to the right or 4 to the left?
To the right.
How do you know? Why not left?
Because the left is negative.
Yeah, left would be negative. Okay. It's y equals 4. So right there, we're going to put a vertical line.
Didn't you just say horizontal?
Yes, horizontal. That's why. It's Lucas's fault. We're blaming Lucas.
Oh.
No, it's okay. I messed up. 1, 2, 3, 4. Right there. Horizontal line at the number 4. So we just go like this. If you have your ID or something like that on a test, you can just use that to make it straight. I mean, it doesn't have to be perfect, but just do it the best you can. That's it. So that's a special case. Y equals 4. How about this one? First of all, is it a special case? What do we think? John, what do you think?
Yes.
Yes, it is a special case. It's only got one letter in it. Okay, which special case? Vertical? Horizontal? I agree, it's going to be vertical because it's x equals. Now, it's going to be vertical at, Stephen, what number?
-2.
Where? So how do I get to -2?
That.
Well, how do I get there, though? Like, how am I going to draw this equation on that grid? So what kind of line are we going to draw?
Vertical.
Vertical at what number?
-2.
All right, so that's what we got to do. Draw a vertical line at -2. Okay, how do I do that? Somebody explain to me, like, what do I do with my pencil? Yeah.
You have to go to the left
Okay, go to the left. How many?
twice.
Twice, and then put a vertical line right there. Right, this one I'm just going to draw by hand, just like that. So it's a vertical line at -2. That means you went 2 to the left. If it was x equals +2, you would have gone 2 to the right. Okay, so any questions on the special cases? Yeah. Yeah. All right, so those are special. Now, we're going to look at the cases that are now slanted. Okay? These cases are going to have an x and a y. All right, the first thing, I just want to ask you guys this question. How many points do you need to draw a line? At a minimum. And as long as you give somebody this many points, they can only draw one line through it. Yeah?
2.
You got to have 2. Okay? You got to have 2 points. So, since you only need 2 points to draw a line, what we're going to try to do is this. We're going to try to figure out those 2 points. There's many, many other points you could find, right? There's millions of points on a line. But does anyone remember what the name of this one is? That's the y-intercept. So we're going to try to find the y-intercept.
That's why you're confused earlier.
And how about that point?
The x.
The x-intercept. That's the other point. If you can find those 2 special points, you can draw the equation of any line. Okay. The only time you'd run into a problem is if it didn't cross one of those axes. Like if you had a vertical line. Think about this. Where's the y-intercept for that one?
Can you go back one?
Yeah. Where's the y-intercept for that? Lucas?
On the left.
Well, where does this line cross the y-axis?
Vertically.
Never does, right? That never will. Here's your y-axis, and I'm asking you where that line crosses that line.
Oh.
Never does. Okay? So vertical is a special case. That's why we did it separate. You can't use what I'm about to show you if your line was vertical. You do it the way we did before. Same thing with horizontal. Now, let's look at the x-intercept. How do we write a coordinate? Which letter comes first? X. And then the second letter? Y. Let's look at the x-intercept. Look at this point. How far up and down? That's the y. How far up and down do you go to get to the x-intercept? Okay, now, how far up or down would you go to get, like if you started at the origin, if you started right there, how far up and down do you go to get to the x-intercept?
None.
None. You don't go up and down at all. So if this is the up-down, and this is the left or right, you don't go up or down at all to get to the x-intercept. So if you don't go up or down at all, that would mean the y value is what? 0. I don't know what the x value is going to be. Okay? Maybe you went right 2, right 3, right 4. I'm not sure. I can't tell you. Every problem's different. But what I can tell you about the x-intercept is you never go up or down to get to it, ever. So the y value is always 0. Since we know that, that's how we can find it. Okay? As long as we know the y value is 0, that's how we can find the x-intercept. Yeah. Yeah, can you speak for the end? Now let's look at this one. Look at the y-intercept. How far left and right do you go to get to the y-intercept?
None.
None. Right? If you start right here, and I said how far left and right to get here? None. You don't go left and right at all. You go up. How far up? I don't know. Every problem's different. Maybe you went up 2, up 3, up 4. But I know that you're never going to go left and right to get to the y-intercept, ever. So because we know that, we can say, all right, the y-intercept is always going to have a 0 for the x value. Always. And that's how we can figure it out. The x-intercept is always going to have a 0 for the y value because you don't go up and down to get to the x-intercept. And that's how we can figure that one out. Right? So it's just going to involve plugging in a 0 for either x or for y. And that's exactly what you guys did in the one. Okay, I think we did one of each. I had you plug in 0 for x, and then I had you plug in 0 for y. And this is y. So, to graph equations that are in standard form, okay, I'm just telling you what we're going to do, and pretty much already told you this. We're going to find the x and the y-intercepts. Okay. You guys also have already answered this, but you probably want to put it on your notes too, just in case you forget. The x-intercept is where your graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. Okay. And if you're thinking, well, what if it doesn't cross an axis? It always will. Only way it would not cross an axis if it's vertical or if it's horizontal. We did those separate. The ones I give you in this one are always going to be on a slant. If it slants, it's always going to cross both of those axes somewhere. Always. So, let's go back for, or you know what? Actually, I think I can go like this. Let's look at that. So, when you're finding an x-intercept, what letter do we always know in the coordinate automatically? Yeah? We always are going to know the y value. I don't care what problem you ever give me. If I'm finding an x-intercept, the y value is always what number? Yeah?
0.
It's always 0. Because you never go up or down to reach the x-intercept. So, to find the x-intercept, plug in 0 for y. And then solve, just like you did in the warm-up. So on your guided notes, it says to find the x-intercept, plug in 0 for y, and solve. All right, now we're going to do the same thing, except find the y-intercept. Anybody think they know what number I'm going to plug in to find the y-intercept? I'm going to plug in 0. Yep. And what letter do you think I'm going to plug it in for? We're going to plug it in for the x. Plug it in for the x. Okay, so it's a little weird, I think, sometimes when you read the directions. To find the x-intercept, you plug in 0 for y. To find the y-intercept, you plug in 0 for x. That's just the way it works, but that's how you have to do it. Again, that might be something handy to put on that extra credit sheet I'm going to give you Thursday. If you forget how to do the x or y-intercept, just copy it from your guided notes. Okay. Any questions just on those 2 steps before we try one? Yeah. Question? Just exercising the fingers. Okay. All right. So it says use intercepts. That means the x and the y to graph the equation, and then label the coordinate of the intercept. Now, can somebody tell me, just by looking at this problem, how do you know it's not a special case? How do you know it's not special? Because if it's special, we're going to do it different. Yeah?
Is it that there's numbers in the equation?
Because there's two variables. There's 2 letters. It's not x equals a number. It's not y equals a number. There's an x and a y. So this is going to slant. All right, so I'm going to give you guys a minute and see if you can figure out what your x-intercept is and what your y-intercept is. So remember what you have to plug in. You have to plug in 0. And remember which letter you have to plug it in for. You're going to plug it in for one letter to find one of them, and then the other letter to find the other one. Also, you will get nice answers. Maybe not always, but in this problem, you should not get any decimals or fractions. All right, so remember the goal here is we're trying to draw a picture of this line. This is not in y equals mx plus b form, right? So we're not using like a slope or anything like that. It's in standard form. When it's in standard form, it's easier to draw it the way I'm showing you. Is this the only way? No. But this is probably the easiest way to draw it. All right, so let's start with the x-intercept. Someone remind me what I have to plug in and where I plug it in to find the x-intercept. Yep, Kelsey, what do I plug in?
You have to plug 0 in for y.
Yes. To find the x-intercept, plug 0 in for y. Right. Kayla, when I write that out, what is my equation going to look like?
3x plus 4 and 0 parentheses equals 12.
Yep. And we did this in the warm-up. 4 times, or 0 times anything, cancels out. Leilani, what's left there?
You divide 3x by 3x.
3x equals what?
3x, you divide by 3x. 3x by itself.
So, yeah, we got 3x by itself, and what about on the other side?
3x 12.
So 3x equals 12. And Jayliana, what would be my last step to get my x-intercept?
Divide 3 on both sides.
Yeah, divide by 3, divide by 3. So when I get, Tristan, what's my x-intercept here?
4.
Yeah, 4, perfect. So that means that this line crosses the x-axis at the number 4. Remember, x-intercept crosses the x-axis. 1, 2, 3, right there. That's your x-intercept. Now, that's not enough. I need one more point, and we're going to get the y-intercept. So how about Joe? How do I get my y-intercept?
So you do 3 3 as 0.
Well, let's start with this.
Oh, x equals 0.
Plug in 0 for x. So your first step, don't do any math, just change the x to a 0, and then just stop. So what would be your equation here?
3 times 0
Yep.
plus 4y equals 12.
Perfect. All right, so there's our first step. Now, how about Princess? 3 times 0? 0, gone. 4y equals 12. And Stephen, what's my last step?
I don't know.
Yeah, you do. You got it. How do you get rid of this 4? Because you got 4 times y. What's the opposite of times?
Divide.
And what would you divide by?
4.
Divide by 4. And what is that? What's that give me?
4.
Yep, and that reduces to
3.
3. Perfect. So y-intercept is 3. Now just put a dot there. Okay. What's the last thing I got to do?
Mr. Hager, I have a question.
Yeah, now draw a line. Question, yes.
Do you ever, are you ever gonna check our binders, or is it just like,
Your notebook?
no,
No, your binder with all the sections that we set up, like guided notes, homework, tests. Nope, that's up for you. That's whatever you want to do with that.
okay.
Okay. Most people, if they're organized, they tend not to lose things as much. That's why I did that at the beginning. Okay, and that's it. There's your line. That's all you got to do. Find those 2 points, draw a line. Now, it might slope down. You might have one that goes up like that. That's okay. Who knows? Might go down, might go up, depends on the problem. What I can guarantee you is if there's an x and a y in it, both, it will never be vertical and it will never be horizontal. Those are special cases. Okay, questions on that one? Okay, let's try, try this one. Okay, so same directions, just find the x-intercept, find the y-intercept, and see if you can make a sketch. So I'll give you guys another, give you like a minute or two to do that. And then when we're done this, we'll do the last problem, which is a word problem. We'll finish with that. Look at it. Okay, let's start with our x-intercept. You don't have to start with that. You can do the y-intercept first. It doesn't matter. You got to do both. So, Julia, how do I get my x-intercept?
U plus 0 for y.
Perfect. Plug in 0 for y. Can you tell me what that'll look like if I do that?
2x equals 4.
Right, because it's going to be 2x minus 0. This y is just going to disappear. So all you have is 2x equals 4. And how about Elizabeth? Once I have that, what would I do on each side to get x by itself?
You divide by 2.
Divide by, yep, divide by 2. And 4 divided by 2?
2.
2. That's my x-intercept. So put it over there. X-intercept is 2. X is which axis? Horizontal or vertical? Yep, horizontal. Okay, so we get that one. Now we need one more, and we're good. So let's find y-intercept. Blake, how do I find the y-intercept?
Plug in for 0
Where?
by y.
So we already plugged in 0 for y. That was the last one. Now we want to plug it in for x. Now, watch what happens if you plug it in. This tripped a couple people up. 2 times 0 minus y equals 4. That's gone. Negative y equals 4. Is that the answer? No. What number is in front of y? It's like a negative 1 right there. How do you get rid of that negative 1? What do you have to do on both sides? Yeah. Yeah, you're going to have to divide by negative 1. And that cancels that out. So what's 4 divided by negative 1? Negative 4. That's your y-intercept. 1, 2, 3. Right there. So when you draw your line, I'm just kind of sketching this one by hand. It's not perfect, but it's pretty good. There's your line. Okay. Question on that one?
I have a question about the test.
Mm-hmm.
Are we getting a study guide for it?
Yep, it'll be extra credit.
When?
Wednesday. Alright, so last one. Same kind of problem. We'll try 2 of them if we have enough time. So it says that you're planning an awards banquet and you need to rent tables, okay, to seat everybody. There's 2 types of tables you can get. You can get small or you can get large tables. And it doesn't matter, as long as you get enough tables to sit 180 people. That's all that you want to make sure you get. So it says with small tables, you can fit 6 people at it. Large tables, you can seat 10. So maybe you're going to get a combination of small and large tables. Okay? Whatever fits 180 people. Well, this is the equation that represents what I just said. They would give you this on the test. You do not have to come up with this equation on your own. Okay? Not yet. Eventually we get into stuff where you do. But that's the equation. Any questions about the problem so far? Small tables fit 6 people, large tables fit 10. You just got to get enough tables for exactly 180 people. I don't think they want there to be extra. Okay? They only want to be able to fit exactly 180. How do I know exact? They put exact. Equals. If they put like greater than or less than, then I'd know, oh, they want to have more or less. No, they put exactly 180. Okay, so x in this equation is how many small tables that you get. Y is how many large tables. So let's graph the equation, and we're going to interpret the intercepts. Now for this one, I don't think I gave you guys the graph. So on the back, we're not going to do practice A. So you can use the grid for practice A if you want. Or you can make your own grid under the question. But I just use the grid on the back. Okay, so let's start with part A. Graph the equation. Okay, Olivia, if I want to graph that, how do I find the x-intercept?
Would it be like, would you have to do like the thing where you like plug in like a 0? Do you
For
do that?
what?
For the y.
For the y. Okay, so let's do that. Let's
Wait,
plug
so
in
is
0
it
for
always
y.
a 0?
What's that?
Is it always a 0?
Yes.
Okay.
Yeah. So we're going to plug in 0 for y. So 6x plus 10y equals 180. 6 6x plus 10, now don't write y, fill in for y, equals 180. Mackenzie, when I do 10 times 0, what do I get?
It cancels out.
Cancels out. 6x equals 180. And how about, Tristan, how do I get x by itself?
Dividing 6.
Perfect. Divide by 6. Divide by 6. Let's check that.
30.
Yeah, it's going to come out to 30. It's like 18 divided by 6 is 3, but just add a 0. So 30. Okay. So x equals 30. Now, that's kind of a big intercept. Right? It's kind of big. So, what might I want to do with my axis? Instead of going by ones, might be easier if I went by, Elizabeth? Yeah, let's just go by tens. Now, I know you guys don't have a ton of room to squeeze in the numbers there, so if you want off to the side, you could just say, go by tens. Because you're not going to be able to squeeze 10, 20, 30 like I'm going to try to do. Yeah, actually, you know what? I don't even really have enough room unless I make it bigger too. So let's go like this. It's a little bit bigger. All right. So we got 10, 20. No, I can fit it. I don't know how high I need to go, but that's probably good enough. 30. So my x-intercept is at 30. Okay. Any questions on that? Maybe you could have gone by 5s too. That probably would have worked. I think 10 is
Where
so.
did you get that graph?
The graph, I would just use practice A.
Oh.
And I would just write off to the side, go by 10s. So on your graph, you're really 3 over, just like me. Okay, so we get the x-intercept. Jaden, what's the other thing I have to find besides that one?
Oh, you have to find the y-intercept.
Yep. And what do I plug in for that?
0.
And what letter do I plug it in for?
X.
Perfect. X equals 0. 6x plus 10y equals 180. So 6x plus 10y equals 180. 6 times 0 is 0. And I get 10y equals 180. John, what's going to be my last step to get y by itself here?
Divide 10 to both things.
Yep, perfect. Divide by 10. Divide by 10. Yeah, and we get 18. So I think what I want to do, I'm going to go by, I don't want to go by 10s. I think I'm going to go by 2s. So is that going to be enough? I think it should be. 2, 4, 6, 8. Yep, perfect. So it said the y-intercept is at 18. Okay. Now, just so we remember what x is, let's scroll back up. X is the number of small tables. Okay, let's label that. So number of small tables. And what was y? The number of, okay, number of large tables. Now, we want to draw our line, but we want to think about it a little bit. Should your line go over here like that?
No.
Why not?
Since we're not having none.
Why? What would that mean if your line went over there like that?
Because you can find more tables.
It'd be a whole, well, why? What would happen? It would, yeah?
That would be in.
Okay, so it would keep going. But how about down here? Should the line go down here?
No.
Why not? Yeah?
Because he doesn't want too many or too not enough.
Well, think about like a point down here. What's the y value of that point?
Negative.
Negative. Does it make sense to have a negative number of tables?
No.
No. That's why when you draw your line this time, all you're going to do is do it just like this. That's it. It doesn't make sense to keep going down below the axis or to the left because you can't have negative large tables and you can't have a negative number of small tables. That doesn't make sense in real life. Okay? It has to just be positive. So there's our graph. It says to interpret the intercepts. Okay. So I want to know what this point means. What does that point mean in our word problem? It has to do with numbers of tables and how many you could buy of each to fit 180 people. Yeah?
The number of large tables you can buy for 180 people.
Yeah, so how many large tables is that?
15.
Okay, so this is 18 large tables. And how many small?
30.
At this point right here. 0. So you decided to just get all large tables, not any small. That's 18 large tables and 0 small. Now, let's look at this one. How many large tables did you buy if you go with this option down here? 0. You said, you know what, I'm not going to get any large tables. Maybe I don't have enough room to fit large tables. So 0 large tables. And how many small? 30. So that's 2 different ways you could fit 180 people. You could say, I'm going to get 30 small tables. Yeah, that'll work. Or just say, you know what, I'm going to get 18 large tables. Or part B, we're not going to do 4. Maybe we'll just do 2. We could get a combination of large and small. So let's see if we can pick one that looks like it's on the line. I don't know. Let's just do this one. That looks pretty good. What would that point represent?
12 large tables.
12 large tables. Yep. So this is 12 large. And how many small?
0, right? No, 1. 10.
10. Let's see if that would actually work. How many people do we want to make sure we sit? We got to fit 180 people. How many people fit at a large table? I forgot.
6.
Large table. 10. So if you get 12 large and you can fit 10 people at the table, that's 120 people. Okay, that works. How many people fit at a small table?
6.
What's 10? So if you had 10 small tables, 6 people, what's 10 times 6? 60.
That's 120 is 100.
That adds up to 180. So any point that's on this line would be an answer to the problem. Okay, if you wanted to find another one, you could probably do this one right here. You could probably get 20 small tables
6 large.
and maybe 6 large tables. Right? So there's different options to fit 180 people.
What's the 100?
And that was part B. So we did one. That's good enough. Okay, so homework. I'll give you guys the review sheet. Remember, no review day this week. We do not have class on Thursday. First test of the term on Friday.
Is the review sheet just on Friday?
Yes,
So, finalize, you can do it?
correct.